Alright, so today we're going to talk about 1.2 translations. So the idea is we're going to take these graphs, we're going to move them left, right, up and down, all that good stuff. Just kind of a little refresher that sometimes these equations don't look like what we've seen before. So we're going to get to that here in the box in a second. But just first idea of the translations. So we have 4 basic translations: up, down, left, and right. So if you take your function and you add a to it, that's going to move it up a units, whatever a happens to be. If you take the function, you subtract a, it's going to move it down a units. So let's say it was f of x minus 2, it would go down 2 units. Now the 2 tricky ones are right here, because it's x plus a in here. The idea is what makes it to get back to 0. So if you moved a to get back to 0, you'd subtract. So minus a, well, which way is the minus direction? On a graph, that would be left a. Here, what makes you get back to 0 would be positive a. That's what would make this 0. Well, which way is positive on our coordinate plane? So this would be to the right. So the way I like to think about it when I'm doing this, and one of the easiest ways for me is to think about is when it's inside the x here, it's like kind of like the opposite. So what's opposite of positive a? Minus a. What's opposite of minus a? Positive a. So I'd go right a. I would go left a if it was fx plus a. So I talked about this a few minutes ago, that sometimes the equation doesn't look like what we want it to. So we have to rearrange it. So I'm going to subtract, in this case, I'm going to subtract 2x from both sides. So we get 15 minus 2x. So then I'm going to divide by everything by negative 5. So y equals negative 3 plus 2/5 x. And when you divide here, right, negative 2 divided by negative 5, it becomes a positive. So if we just rearrange this, now that looks like a linear equation that we've seen before. We know the slope and the y-intercept. So sometimes these equations are going to have to be tweaked a little so that it looks like something we've seen before. So again, just a review of some of the parent functions we're going to deal with. So we have a regular, just random function here. We have a linear function. We have a quadratic. We have an absolute value. And we have exponential. Right, so there's the graph. So what we're going to do is we're going to move these graphs in different directions. Left, right, up, and down. They're going to stay exactly the same. We're just going to shift them some way. Okay, so first one, we're going to have f of x plus 3. So we want to describe it. So plus 3 means you're going to go up 3. So I'm going to take the points and move them up 3. I'm not going to move every single point. I'm going to choose a few key points, move them, and then just retrace the graph. So I'm going to move this point 1, 2, 3 up. Next point here, 1, 2, 3. Here, 1, 2, 3. Here, 1, 2, 3. And then just reconnect the graph using the graph below as a guide. Okay, linear function, x is to the first power. So here's your parent function. Now this tells me to subtract 4, so it's going to move down 4. So I'm going to take those blue dots and move them down 4. 1, 2, 3, 4. 1, 2, 3, 4. And then just reconnect the dots. So there's your translation. Okay, quadratic, right? Parent function for this one is 3x squared. So now it's been shifted 4 units. Now, if it was out here, that would be up or down. Inside is left or right when you're inside with the x, with the grouping symbols. So what makes this equal to 0 is positive 4. So which way is right 4? Or, well, sorry, just answer that for you. Which way is positive 4 is right 4. So 1, 2, 3, 4. And then move this point and this point right 4. Right, 1, 2, 3, 4, and there you go. There's your translation. Be careful again, right? What's in here is what makes it equal to 0. It's what gets it back to that origin. So this would be to the left 2, because what makes this equal to 0 is if x is negative 2. So that means left 2. So 1, 2, 1, 2, 1, 2. So there's your translation. And again, I'm not moving every point. I pick a few key points, move it, and then just retrace the graph using the original as a guide. Okay, now, number 5. Well, that doesn't look linear. Well, this is actually what we call point slope. This is a type of linear equation. So here's your slope, here's your point. So this has been shifted twice. It's been shifted to the right 2 and down 3. Why right 2? Because what makes that equal to 0 is positive 2. Positive 2 is to the right. This is down 3. So I'm going to move this point right 2 and down 3. 1, 2, 3. Move this point right 2, down 3. And then I just reconnect the graph. Right, reconnect the dots, and there's my function. There's my translation. So now we got a quadratic. Here's the parent function sketch down there. So this is, again, what makes this opposite. So this would be to the left 2, because it's negative 2, which makes this equal to 0. And then you're going to go down 3. So I'm going to move the vertex left 2 and down 3. Left 2 and down 3. And there you go. And if you want to write it out, you can write left 2, down 3. I just like to use the arrows because it's a little quicker. Okay, same idea as the quadratic. Again, to the right 3, up 2. Why right 3? Because what makes this equal to 0? Right? Positive 3. That's in the right direction. So 1, 2, 3, up 2. Right 3. And there you go. Okay. Then the last one. So here's the parent function, right? This is a sketch of y equals 3 to the x. But now it's been shifted. So to the left 1 and up 4. Again, why is it left 1? Because what makes that equal to 0? Negative 1. Well, where's negative 1? That's left. Negative means left. It's a direction. So move the points left 1 and up 4. 1, 2, 3, 4. Left 1 and up 1, 2, 3, 4. And then there's your sketch. And then now your asymptote is right here. Okay. So those are some basic translations. Right? Left, right, up, and down. Again, coming back up here, it all relates back to this part right here. Understand these. And for most of you, it's going to be those two right there that are going to be the tough ones to remember. Okay. So if you flip your notes over, now we're just going to kind of work with some of the notation and practice some of our graphing. So this is what we call a composite function. So this means you're going to plug G into F or F into G. You work inside out, just like order of operations. So this is telling me to take whatever G is and plug it into F. So I'm going to take this function and plug it in there. So this is what I'm substituting in. So I'm going to write x minus 4 squared. Right? I replace the x with the x minus 4. So now I'm going to sketch that. Well, that's a parabola that opens up. Okay, it's been shifted right 4. Right, the vertex is 4, 0 now. So 1, 2, 3, 4. Right, remember our little rule, 1A, 3A, 5A that we talked about in 1.1? Well, A in this case is 1, so right 1, up 1, left 1, up 1. Right, A is 1, so right 1, up 3, 1, 2, 3. Left 1, 1, 2, 3, and up 3. It's always left or right 1, it's up or down, whatever these turn out to be. Again, A is 1, so 1, 3, and 5. And there's your sketch. And again, we need our 3 points. Okay, so next one, take G, plug into F. So here's G, plug it into F. So 3 to the x minus 1 minus 2. Okay. So now just remember though, the key point was 0, 1. Now it's been shifted to the right 1 and down 2. So over here was 0, 0. Now it's 0, 1. It's been shifted. So if we go right 1 and down 2, there's the new key point. Okay. So now when you're graphing these, right, what I like to do is to make it a little easier, I like to think of the parent function. I'm going to do that in a different color. So 3 to the x. Remember that table we did? We had x, we had y, -1, 0, and 1. We did this in our notes, 1.1. So this would be 1/3, right, 1, and this would be 3. So if you were to quickly sketch that, that would look something like this, right? That's the parent function. Well, now it's been shifted. Okay, so these 3 points have been shifted. Right 1 and down 2. Well, we already shifted this point here in the middle, right? The dark blue one here. It's here. So if you just shift this one right 1 and down 2, and this one right 1 and down 2, now you have your sketch. This is your composite function now. So what I like to do is I like to look at whatever this number is and quickly sketch that parent function. Right, so I sketch the 3 to the x, that's the graph in blue, and then I just shift it. And I'll show you that again a little later, but that to me is one of the easiest ways to do it. Okay, now if you look here, again, f goes into g this time, so this is going to be plugged in here. So now you get x minus 4 plus 2. And again, this is what we call a composite function. It's composing multiple functions. Okay, so now this has been shifted to the right 4 and up 2. But shifted from where? Well, the origin. So right 4, 1, 2, 3, 4, and up 2. And how do I know it's the origin? Because I remember back to our 1.1 notes. And the key point for absolute value, quadratic and linear, is 0, 0. Exponential is the only one that's different. That's 0, 1. Okay, so the slope is 3. So up 3 over 1. Up 3 over 1 to the left. So there is your sketch. Okay. Okay, so we're going to graph and label f of x and g of x and then describe the translation. So these are two linear functions, so I would recommend if you're doing this trying to use a different color. One for one and one for the other. So I'm going to do this one in green. So this is a line. It's been shifted to the right 3 and down 4. From the origin, 1, 2, 3, and then 1, 2, 3, 4. The slope is up 1 over 2, up 1 over 2, down 1 over 2. Okay, there's your graph. Right, so that is f of x. And since I'm doing multiple graphs, I'm going to label them. So I'm going to do this one in a little pink color. So this is to the left 2 and up 3. And the slope is up 1 over 2, up 1 over 2, down 1 over 2. And there's your graph. Right? So that is g of x. So now I want to describe the translation. So I'm going to pick my 2 points that got shifted from the origin. So this point and this point. Those are the 2 that moved from the origin. Right, that was the shift. So how do I go from the blue dot to the blue dot? And we're going from F to G. So how do I get from this red dot here to that red dot there? Either up or left, doesn't matter. So I'm going to go 1, 2, 3, 4, 5. So in this case, we're going to go 1, 2, 3, 4, 5 left. So we're going to go left 5, and we're going to go up 1, 2, 3, 4, 5, 6, 7, up 7. All right, left 5 and up 7. So we want to write this in notation. So we have x, we have y. So we went up 7. All right. And right? We went left 5. Okay. So coming over here, same idea. Now we have two quadratics. So the vertex has been shifted from the origin to the left 2 and up 3 for this one. 1, 2, and 1, 2, 3. It's a negative 1. Right again, so 1a, 3a, 5a. So 1, negative 3, negative 5. Because a is 1. So over 1, down 1, over 1, down 1, over 1, down 1, 2, 3. So there's your graph. Alright, so that's f of x. And then we're going to do g of x, which has been shifted to the right 5 and down 1. So from here, 1, 2, 3, 4, 5, and down 1. And again, it's a 1, so it's a 1, 3, and 5. Over 1, down 1, over 1, down 1, over 1, down 3. Again, 1a, 3a, 5a. Again, this is a negative 1, so these are negative. So how do you go again? This is g of x from this blue dot to that blue dot. So we can go right 1, 2, 3, 4, 5, 6, 7. So right 7 and down 1, 2, 3, 4. Down 4. So we have x, we have y, we went down 4, we went right 7. Okay. And that's how you use the notation. Again, composite functions, and then working on our translations. Make sure you answer your essential question in your summary.